Welcome to the Unit 3 homework video tutorial for pages 11, 12, and 13. We're going to go ahead and get started. I'm going to go ahead and show you how we are going to approach this page. A lot of times I see students only circle and not also write the name. So that's not what we want you to do. Make sure you're writing the name in addition to doing your circling. So I'll go ahead and start with number 1. Okay, this needs a Roman numeral because I have PB, which is lead. Remember, we are going to use each of our steps every single time. So step 1, I am going to change this symbol to a name. So this is lead. Okay, I know it needs a Roman numeral. I'm not exactly positive on that yet, so I'm just going to write in my parentheses, and then I'm going to take a look at this. That is nitrogen, so I'm going to turn that to nitride. Almost always you can just use the anion for your Roman numeral, and that is what I'm going to do right here. So this is lead for nitride. Okay, so this next one is already circled for you, so I'm going to go ahead and get into this. Notice immediately there are no subscripts, so we know we're going to have to do a little extra detective work. This is chromium. I know it needs a Roman numeral, but I'm going to leave it blank for now. And then O is oxygen, which we're going to change to oxide. Okay, so when I'm approaching a problem that does not have any subscripts at all, what I want to be thinking is these are both the same. This has an oxidation number, but they are both the same number, and they have therefore canceled each other out and reduced. So I can solve this just by thinking, what is the oxidation number of something I know for sure? I know for sure oxygen has a -2. That means Cr also has to have a +2, because in that case they will have reduced down to this formula. So this is chromium 2 oxide. Okay, now sometimes you have these mixed problems that you might want to be checking to make sure it doesn't just have a polyatomic ion right here, but I'm also going to find CD on the periodic table, because remember, our step 0 is always going to be thinking, would this require a Roman numeral at all? Sure enough, if there is CD, number 48, it definitely needs a Roman numeral. So I am going to write down cadmium, because that's what it is. I'll leave that blank and come back to it. And then I want to look at what's inside my parenthesis. My parenthesis is my hint that what I am dealing with is a polyatomic ion list. Lucky you, we don't have to memorize these. We just need to match it up. So I'm going to look for the formula that matches exactly what is inside my parentheses, and that is acetate. So then I'm going to write that down. There it is, cadmium. And we are lucky again here because this has a nice little subscript, and that makes it easy for me to fill in my Roman numeral. Okay, so I'm going to say cadmium 2 acetate. Okay, so not everything needs a Roman numeral. We want to be careful to think about our exception block. Our exception block is silver, zinc, cadmium, aluminum, gallium, and indium. So if it falls within that exception block, we do not want to name it with a Roman numeral. Okay, so what I'm going to do here, I know zinc is an exception. I do not need to circle it because it does not need a Roman numeral. So I'm just going to write it out. Zinc, and S is just sulfide. And again, right here, this will probably be the same situation, right? It's silver, which is also one of our exceptions, chloride. All right, moving on. Number 12, what is the formula for titanium 4 hydroxide? Okay, so it's a 4-step formula. When we're going over from the name to the formula, our step 1 is going to be changing the symbol changing the name to a symbol. So the symbol for titanium is Ti. Sometimes it's easier for some people to do steps 1 and 2 at the same time. So step 2 is writing in the charges. I like to do them at the same time. I know that the oxidation number has to be 4 because that's what the Roman numeral is telling me. So I'm going to write in my +4. And then I'm going to write out my polyatomic ion for hydroxide. Remember, if it ever seems like an unusual name, one that you wouldn't really see normally on the periodic table, it's a good hint. You should use this list. So there's hydroxide. It is OH, and the oxidation number on it is -1. So I'm just going to fill that in here. OH, -1, and then I can swap. Okay, so that 4 is going to crisscross, jump down. We can't do any other reduction, so our final formula is going to be C. If you're wondering where the 1 went, we don't usually write the 1s out. They are understood to be there. Okay, keep on moving. Number 15, what is the name of the compound CuClO3? Okay, so we're going to go backwards from what we were doing before. Now we have a formula, and we're going to write out our name. Always be thinking, step 0, does this need a Roman numeral? And copper does. Why? Because it is a transition metal. It is right here. So that means it will need a Roman numeral. Copper. I'm not sure what it is yet. I'm going to put the parenthesis in to remind me it needs to be there. And then I am going to, I see parentheses. That's my hint. I need to check my polyatomic list. Alright, so I'm going to find ClO3. Okay, so ClO3. We can find that right there. That is chlorate. The charge on that chlorate is a -1, and that is what I'm going to use for my Roman numeral. Remember, we always get our Roman numeral from the anion. So, I can see that this is a good answer choice. And I want to get rid of things like that. Because if it doesn't have a Roman numeral, then it can't be correct. Copper always needs a Roman numeral. Okay, moving on to the next page. Here we are on page 12. I am going to start with number 2. Again, this time it's saying circle all the names that are binary. Binary means it does not include a polyatomic ion. So if I see this IDE ending, I know I should not be looking at my polyatomic list. Okay, so this is going to be a binary. I would circle it. So, step 1, I'm going to change this mercury into a symbol, Hg. Depending on your preference, if you think it's easier to combine steps 1 and 2, you might want to just include the charge here. This +2 came from the Roman numeral 2. Don't look at the periodic table for this. Always use what the Roman numeral is telling you. Because this is binary, I don't need to look at my polyatomic list. I know it's just nitrogen. Nitrogen has an oxidation number of -3. And then they're going to crisscross and jump. Now that I've crisscrossed, I know it can't be reduced, and I'm going to move on. Number 4 is an example of something that does have a polyatomic ion. I know that because it has an unusual sounding name. It is perchlorate. That is not the same thing as chloride, so I'm going to not circle this one. Okay, manganese, not magnesium. Manganese is a transition metal, so we're going to write that as Mn. I like to go ahead and include the charge in the step because I'm thinking about it. It is 2 + 2. Perchlorate, I'm going to check my list. Alright, there it is, perchlorate. So perchlorate, I'm going to copy my formula down exactly as it appears. ClO4 inside the parentheses, and the -1 here is the oxidation number. ClO4, -1. Then they're going to crisscross. So the 2 will come down here. The 1 will come right there. And I'm all done. Okay. Silver iodide is another one that is binary. So I'm going to give it a circle. The symbol for silver is Ag. The symbol for iodine is I. Next step in our four-step formula is to include the charges. Silver is one of those that is in the exception box. Even though it is a transition metal, it is right there in the transition box, and it always has a +1 charge. Iodine always has a -1 charge. They're going to crisscross, so each one will come down, and you are finished. If you want to, you can erase the ones, because we don't need them. Okay, number 9 says, which Roman numeral will be used to name COCl2? This is one of those where you have to think a little bit in reverse. You do not know for sure what CO is. That's what we're going to do some detective work and find out. You do know that chlorine always has a -1, right? So that would come down there. So if they swapped, we know this CO would have to have a 2. And a lot of times, if there is a subscript on the anion, a lot of the times that's just the answer. In this case, it is. Sometimes you have no subscripts, and then you have to work a little bit backwards. Okay? So, if I was naming this, I would say iron. I know this needs some kind of a Roman numeral. I have to work a little bit backwards. If they are both without a subscript, you need to assume that they're just the same number, one being positive, one being negative, and that they've canceled each other out. So I'm going to name that oxygen oxide. I'm going to think about that oxygen always has a -2 charge. Therefore, it is iron 2 oxide, which is choice C. Alright. Last page. Great job. This is molar mass. So for this portion, you would need your calculator. Okay, I've got a CI30, which will get the job done. So I want to begin with this first one here. It's asking about the moles of Al. So I'm going to think about this here. I'm going to look at my formula. I can see we've got 2 Als there. So I'm going to say 2 times the molar mass of aluminum, which is 26.982. So I'm just going to round that to 26.98. Plug it into my calculator. And that is 53.96. Okay, same thing for oxygen. I can see here in my formula, I've got 3 oxygens, and I know the molar mass from the periodic table is 15.99. So I'm going to say 15.99 times 3. And I put this all in parentheses, honestly, because that can give me my total mass, but you can also do it in 2 separate steps. So I'll show you, if you wanted to do it in a different 2 separate steps and just add them together at the end, that works too. So 15.99 times 3. And then added together, you get your total of 101.93 grams per mole. Okay. So I'm going to do number 4 now, which is asking you to come up with a formula. So 4-step formula, we know calcium is Ca. And sometimes I like to combine steps 1 and 2 and include the charge right away. Calcium has a charge of +2. hydroxide, I know that's going to be on my polyatomic list. That is OH with a charge of -1. They are going to swap. So I've got 1 calcium and 2 hydroxides. So I'm going to do the same thing as I did before. Ca, I'm going to say 2 times the molar mass of calcium, which is right there, 40.078. I'm going to round that a little bit. And hydroxide, you have to do it in 2 different steps, right? Because we have O and we have H. That's what's in hydroxide. So I have 2 hydroxides. Ooh, I messed that one up. I'm going to go back. I just realized I did this wrong. I only had to do 1. My apologies. I'm so sorry. That's why it's important to write out your formula correctly and pay attention to what you're doing. There's only 1 of those. Okay, so we have 2 hydroxides. My apologies. We have 2 hydroxides. So our O is going to be 2 times the molar mass of oxygen, which is 15.99, right? Because we have 2 oxygens and we also have 2 hydrogens, so we got to finish that off. 2 times the molar mass of hydrogen. There it is. It's 1.008. And if you want to, you can do it all in a single step in your calculator. You can either do it all in a discrete step, or if you feel comfortable doing parentheses, you can put this whole thing in parentheses. You can say 1 times 40.08 plus 2 times 15.99 plus 2 times 1.008, and then just hit enter. But if you're going to do it that way, you have to be very careful to use your parentheses, but it could save you some time as long as you are very careful. If not, you can do them in discrete steps and add them all together at the end. Okay, so that's my total, 74.076. Okay, so like I said, if I wanted to, I could have just written it out this way and then added them together at the end, right? So I could have done 15.99 times 2, and then I could have done 2 times 1.008, so give me 2.16, and then just added my 3 numbers here. Or if you want to do the parentheses, you can do it that way. Just be careful if you do parentheses to close them. Follow order of operations. Alright, so last part. How many molecules are in 1 mole of NH3? So how many molecules? The interesting thing about molecules is that 1 mole of anything, 1 mole of basketballs, pizzas, water, anything, 1 mole, that is an amount. The amount in a mole for molecules is always going to be this number right here, Avogadro's number. Okay, so same thing, if you see the word atoms, same idea. Okay, how many atoms is the same thing as saying how many molecules. And we've got only 1 of them, just like before, so we know the answer has to be 6.02 times 10 to the 23rd. Okay, this is different than molar mass. You see the word molar mass, then you're going to be using the number on the periodic table. So there's carbon, and its molar mass is 12.011. So I'm going to find that choice, and there it is. So that was the video tutorial, and we will see you next time.